British Office Taipei, Head of Economic Cooperation and Growth Section, Xi'an Desai, Taiwan Automation, Intelligence and Robotics Association, Chairman Xi, International Federation of Robotics General Secretary, Ms. Suzanne Bieler, distinguished speakers, industry representatives, and guests who is online with us, greetings to everyone. Today, I'm honored to have the opportunity to speak online in this capacity to this year's UK-Taiwan AI and New Technology in Smart Manufacturing online seminar. Once again, greetings to everyone watching. On behalf of Taiwan's Ministry of Economic Affairs, Industrial Development Bureau, I extend my welcome to the industry pioneers in the manufacturing field from Taiwan and the UK. And the dialogue exchange in new development and business opportunities of advanced technology for smart manufacturing in recent years. Taiwan's government and industry both view innovation, productivity, and quality improvement in the manufacturing industry as important economic engines. The continuous shaping of industrial partners through dialogue exchange can amplify and accelerate the progress of smart manufacturing to promote the practical application of AI and new technologies by small and medium-sized enterprise to create new values and stimulate large enterprise to allocate for international market and drive the industry chain. IDB's effort in elevating Taiwan into Asia high-end manufacturing hub through the smart machinery policy has been remarkable feedback from industries. Since 2019, the Bureau has implemented the AI plus Smart Manufacturing Industry Promotion Program, with dedicated resources to help domestic enterprises adopt applied AI module within manufacturing, such as for enhancing machining and inspection process. Taiwan's companies have been eager to utilize expert capability and drive upstream and downstream supply chain to improve together. The program up to today has helped over 13 industries, including machine tool, textile, and plastic products, aiding in developing innovation application to solve actual problems in raw material preparation, manufacturing scheduling, equipment efficiency, and quality management. So far, creating 56 lighthouse use cases. The program also supports the nature of many solution and system integration companies, raising the overall industry chain resilience in Taiwan. Taiwan's machinery industry has demonstrated its resilience under the test of pandemic and the volatility of the international supply chain. The value of machinery industry production in 2021 reached an all-time high of 1.3 trillion Taiwan dollars and 347 billion British pounds, a 27% increase compared to 2020, delivering outstanding progress. Taiwan's and the UK's bilateral trade in 2021 reached 5.75 billion British pounds, a significant increase of 13% compared to 2020, making UK Taiwan's third largest trading partner in Europe. In addition, as of April this year, Taiwan investment in UK has over 226 cases, ranking second in terms of investment cases in Europe. As for investment amount, the total amount of investment reached 2.81 billion British pounds, accounting for 25.95% of Taiwan's total investment in Europe. The total number of British investment in Taiwan reached 1,333 cases, ranking first, with an investment amount of 9.55 billion British pounds. This showed that both sides have business opportunity and strength in the international market, and that there is close cooperation between the two industry countries. The UK has top-tier software, AI, and industrial innovation capability in Europe, while Taiwan has a world-class smart machinery and manufacturing industry. I believe that by exploring opportunities for cooperation in manufacturing and new technology applications. Lastly, I want to thank all the industry audiences for your participation, and I want to acknowledge the smart manufacturing, AI, and industry experts from UK and Taiwan for sharing your knowledge and advanced manufacturing technology. I wish for fruitful and productive discussion and a successful event. Thank you, and continued good health and success to you all.
Good morning to all our UK participants, and good afternoon to everyone here in Taiwan. Let me start by thanking IDB Metal and Mechanical Industries Division Director Ling, TAIROA Chairman Si, and International Federation of Robotics General Secretary Dr. Bila for helping make this event happen. It is with great pleasure that I welcome you all to the second UK-Taiwan AI and Smart Manufacturing Conference. In the past few years, we have seen a huge growth in the use of digital technologies, transforming both business and society. The potential for these technologies to drive growth and raise living standards is spectacular. It is estimated digital transformation could grow the UK economy by over £400 billion by 2030. That's equivalent to around a fifth of last year's GDP. The UK government is working hard to capture these opportunities. Our digital strategy, published earlier this year, sets out our vision and ambition for strengthening our global position as a science and technology superpower by 2030. The UK already has a flourishing digital ecosystem, with Europe's largest data market and over 120 unicorns. In the first 5 months of this year, UK tech companies raised more venture capital funding than in the whole of 2020. This put the UK second only to the US when it comes to startup investment, outperforming China, France, and India. In today's fast-changing world, it is essential to think and work collaboratively about the manufacturing industry of tomorrow. Taiwan is a leader in smart manufacturing, inventing various technologies, as well as many applications, from high-precision cutting machines, power presses and machine tools, to industrial automation and robotics. Looking at the complementary strengths of both the UK and Taiwan in this area, it feels there is fantastic potential for both partnerships and collaboration. This is the reason why we at the British office are so excited to see this forum enter its second year. The coming hours will give you many opportunities to hear from your peers and from different experts, drawing inspiration from their innovations. I look forward to seeing how today's discussions lead to partnerships in the future. Thank you to all of the companies and experts who are contributing, and good luck. I hope everybody enjoys the seminar. Thank you.
Good morning in UK. Good afternoon here in Taiwan. My name is Kuo Su. I'm chairman of Taiwan Automation Intelligence and the Robotics Association. I am much delighted to welcome you to UK-Taiwan Smart Manufacturing Technology Advancement webinar. For last decade, investment in smart manufacturing have contributed a lot to GDP and employment growth in major industry countries around the world. Taiwan has very competitive supply chains for machine tools, electronic, semiconductor, and in particular, smart manufacturing component industry. This webinar is to create more cooperation opportunity between Taiwan and the UK in smart manufacturing. We invited several distinguished experts to share their experience in robotics, carbon reduction, and information security. I do hope this event will inspire participants today new ideas for business growth in both countries. Again, welcome. Wish you a successful webinar and thank you very much.
Ladies and gentlemen, dear participants, it's a great pleasure for me as the General Secretary of the International Federation of Robotics to welcome you to this UK-Taiwan online seminar jointly organized by ITRA and the British office in Taiwan. This great event greatly combines two very important aspects of today's business. First, updating existing production technologies into smart manufacturing lines, which is key to competitiveness, a prerequisite for companies to survive and to thrive in today's challenging times. Second, international collaboration cooperation. In times of increasing political confrontation and decoupling, we need to emphasize even more that we are much better off working in a team where several players bring in their specific strengths and skills. Robots are versatile tools that promise a lot of benefits for manufacturing companies. They provide a high flexibility to quickly adapt production and to respond to changes in demand and small batch sizes. And robots also help to improve the resilience, to deal with production peaks and to withstand systemic shocks such as COVID-19. When it comes to reaping the benefits of industrial robots in advanced manufacturing, Taiwan is well situated as an emerging market for industrial robots, with a focus on the electrical and electronics industry. It ranks 7th on a global scale in new installations in 2021 and 8th in robot density. With its focus more on software and services, the UK has still some room to catch up. There has been a lack of investments in advanced manufacturing technology, especially in robotics, in the years before the Brexit. This leaves the UK at rank 24 in robot density, with only 111 industrial robots in operation per 10,000 manufacturing employees. This is well below the world average of 141 robots and less than half that of Taiwan, and overall a very low number for a Western country. This is also manifested in the installation figures, with only 2,000 robots newly installed in factories in the UK in 2021. That's a minus of 7% compared to the previous year. The country ranks number 20, just after Czech Republic and just before Malaysia. This is also roughly only a fifth of installation we see in Taiwan. Why is this? The main reason for this can be seen in the fact that for many years the British economy focused on the attraction of relatively cheap labor from Eastern European countries. This made investments in advanced production technology comparatively less attractive. With the decision to exit the European Union, this trend was reversed, as workers were concerned about their future work prospects in the UK. Today, the UK is facing a massive labor shortage, and the pandemic did nothing to improve this situation. We can see this development particularly in the automotive industry, the largest customer industry in the UK, that uses comparably less robots than their counterparts in the continent. So if you look at the particular robot densities, the robot density in the automotive industry in the UK is roughly half that of the continent. And the number of installations in this industry in the UK even went down in the past year by 42%. On a positive note, we can already see first indications of change, particularly in the general industries, that understood the needs to invest in automation technology to keep up with international competitors. In particular, this is the plastic and chemical products industry that was up in robots installations plus 25%, and the metal industry even more than tripled their installations of industrial robots last year. This trend is supported by the efforts of the British robotics industry, represented by the BARA, the British Automation and Robotics Association, to speed up the robotic system integration skills. This is a very strong and necessary pillar for the manufacturing industry to increase the use of robots and automation. And this, again, wouldn't be possible without international collaboration. And this integrated certification scheme that has been established in the UK in the previous years has been a result of a very close collaboration of the UK with the North American partner A3. With this in mind, the IFR is welcoming this initiative by ITRI in the support of our long-standing member TAIROA to foster further international collaboration and dialogue between the two countries, to reap the benefits of Industry 4.0, to upgrade manufacturing, and to implement the latest technological developments to advance the economies. A big thank you to this. With this in mind, I wish you all a very pleasant and successful event, hopefully many new business contacts and lasting partnerships. And I hope we will see the effects of this effort already soon.
Good day, everyone. I'm Camus, the chairman and founder of Touche Solutions. In the past decade in the manufacturing, operators usually work side by side, and we keep robots in a cage. Keeping humans and the robots separation has been our only method for automation so far. If we want to transform the traditional manufacturer into a smart factory in a way that is flexible and productive, as ever, there are challenges in safety, space, speed, and automation complexity, which means cost. A trend in robot use human-robot collaboration. Robots inside of the safety fence is now changed into a robot without safety fence. Repetitive industrial tasks can be easily performed by traditional robot systems, and more tasks require humans to help. Human-robot collaboration provides an ideal concept of co-working between human operator and a robot. So robots share workspace with human, and the ultimate goal is to achieve the physical interaction. But this provides more chance of contact and the complexity of safety measures. So now here is a web of collaborative robots. You can see more and more working space. There are robots co-work together with humans, and they provide a lot of help for human operators. And this is not just in industrial environment, but it will be everywhere. And as we can imagine, the more intelligent of a robot will provide, the more possibility of physical contact between human and the robot. So in fact, the collision risk between human and the robot is steadily increasing. Since the collision is unavoidable, the challenge should focus on the post-collision phase to control the allowable biomechanical limit of force and pressure. when the accident happens. This is what we are doing, the T-skin, the tactile skin. Imagine if we could easily upgrade the current robot to perform tasks safely together with humans without the need of a fence. We are making it a reality with T-skin, an innovative add-on solution that can quickly transform industrial robot to safe collaborative application with a high sensitive tactile skin on the surface of each robot arm. The T-skin is compliant with the new ISO standard for safety functions and their functional safety requirements with power and force limiting safety function. Robot can only impact limited force to human body in any contact event. T-skin is designed for industrial environment. It is sensitive and robust. Moreover, the skin module can be easily installed or removed. User has the option to using the same robot in both traditional automation or collaborative applications. T-skin can upgrade traditional robot into high-speed creative cobots with zero compromise. We have a rich portfolio of T-skins for different types of robot, from Scala to 6-axis arm. And we also co-work with leading company for their next generation robot with design in T-skin. They are high sensitive. For example, this is the T-skin co-work with Kawasaki Heavy Industry. There are high sensitive sensors on the surface of each skin module. It connects to the emergency stop system of a robot and provides safety protection. Comparing with the popular cobots in current market which use torque sensors, the solution with T-skin plus industrial robot have more advantage. We provide a large payload, an option, better precision, and higher speed robots. And the T-skin can comply with a lot of certifications in health and safety. For functional safety, product safety in CE and UL. And we also get the collision measurement report from peers for biomechanical limits. And this global compliance enables global users to solidify their requirement and not to have it be modified country by country. So with T-skin, the robot can work safely together with the humans. Here is a case study published in IFR. This is what we did in Taiwan's manufacturer, Kista. They use ABB's robot with T-skin. This is the first collaborative production line using industrial robot with T-skin. In fact, only 10% of tasks can be fully automated in an electrical production assembly line. So T-skin, they adopt industrial robot with Touché Solutions T-skin to create a safe human-robot collaboration environment. In Kista's human-robot collaborative production line, robots are responsible for heavy, repetitive, and high-precision tasks, while humans attend to tasks requiring flexibility and judgment. The capacity per square meter increased by 52%, and the production efficiency increased more than 80%. Okay. So now we have partnership with top industrial robot manufacturers. We co-develop with robots headquarters, for example, Kawasaki and Denso Web. And we also go marketing and sales with local branch, for example, ABB, Epson, KUKA, and Mitsubishi robots. We all know global sales of industrial robot has reached a new high record of almost 500 units last year because of the labor shortage and the increasing demand in electronics and electric vehicles. And T-Skin can enhance robot with more flexible automation to save the space more than 50% and provide the fast ROI playback with traditional robot. Especially, we provided the flexibility of automation in a post-COVID-19 era. Finally, we are a spin-off company from Industrial Technology Research Institute in Taiwan, and we have more than 10 years developing robotic sensing systems, and we have a multitude of patents and certificate already on the application of our products. So thank you for your listening, and if you have any question, please contact to share solutions. Thank you.
Welcome to attend this conference to share the story of Herco Automation Limited with us. I'm Zheng from Herco Automation Limited, Taiwan. At first, let's talk about the Herco Automation Limited. We are founded by Herco Company, USA, and the Taikon Enterprise, Taiwan, in late 1996, and serves as a main CNC control ODM partner of Herco Company initially. After years of automation product design and manufacturing for Herco, we start to provide PC-based solutions to control and automation, include motion control technology, field bus technology, sub-logic technology, HMI technology, AI and IoT technology, and so on. We provide total solution of motion control to fulfill all the requirements of machine control and automation, from traditional servo interface to digital servo, from NC interpreter to motion interpretation. We also provide field bus technology, complete industry field bus master and slave technology are supported, so we can work from sensing to control. And for instance, we provide EtherCAT, maturing the interface, device-net interface, and for some encoder module, we provide BSC interface and NDOC2 interface. Standard sub-logic technology. Industry standard sub-logic functionalities include ladder diagram, structural test, and sequential function chart are also supported. Then, the HMI technology. We provide total solution of HMI hardware, platform, and software tools to ease the development of human-machine interface for end user. Simulation technology. Advanced 3D simulation technology for multi-axis CNC mill, lathe, grinding, and tube bending application are supported. Then, the AI and IoT technology. new AI and IO technology to boost the control performance and enable the enterprise-level integration of process. Hardware, OEM, and ODM. We have massive successful OEM, ODM products from CNC control, EDM control, tube bender control, tool grinder control, to gear hardening control. Finally, we have branches and partners worldwide that can deliver our technology and service repeatedly, from Taiwan to North America, Latin America, Australia, Europe, UK, China, and Southeast Asia. Let's have a look at the advance on AI and IoT technology of Herco Automation Limited. At first, IoT-enabled machine control. Enabled IoT technology of a leading CNC machine builder, TAIROA in Taiwan. We provide the connectivity of their machine to MES, NAS, ERP, and provide remote accessibility of their machine to boost the efficiency of the end user's production. Application example 2, AI CNC tool grinder. In this case, to speed up numerical optimization process of fluid design of mill tool, to get good initial guess of grind wheel start setting of end mill tool's fluid grind calculation. By feeding a set of tool specification and the grind wheel specification to neural network, then a set of initial guess of grind wheel setting is obtained. Include the wheel setting angle, distance between wheel axis and the tool axis, and the grind wheel axis displacement amount. For the assistance of the neural network, we gradually improve the efficiency of the grind wheel fluid design process. Finally, the CNC spindle AI compensation. Recently, we use the temperature of spindle bearing, include the front bearing, the back bearing. Their temperature maybe include the machine or environment temperature and other operation status. For instance, the spindle RPM and the heating cooling time, to successfully predict the CNC thermal displacement precisely by the neural network. Finally, we can predict the thermal displacement of the spindle in the error less than 2 micron. That's about what the Herco Automation Limited work on the AI and IoT field these days. Thank you for your listening.
Hello, everyone. I'm Theo Saville, co-founder and chief executive officer of CloudNC, and I'm here today to tell you about how we are working to make precision manufacturing programming of CNC machines a single-click autonomous process. As most people on the call will know, everything that is manufactured needs precision parts. It's a multi-$100 billion industry that is reliant on for everything from the production of vehicles to aircraft, satellites, defense equipment, construction, medical. There is almost nothing that we can manufacture without very precisely made metal and plastic components. And as we know, precision parts are made with CNC, or computer numerical control machines. But there is a very serious problem with these machines, and that is that they are not autonomous. If we want to use one of these machines to create components, we must incredibly painstakingly program them, requiring masses of expertise before we can actually produce a component. It's not like using a 3D printer, it's not like using a desktop printer. We must be incredibly expert to use one of these machines. So if we want to have precision components produced, then we have to go through an incredibly lengthy, manual and difficult process of manually quoting for components, manually scheduling our factory, manually programming the machines and testing our programs because we don't always get it right the first time. In fact, frequently we get it wrong. And we must manually monitor the machines and keep them producing correctly. And as precision manufacturing is such an incredibly high-mix industry, much of the automation that can be found in mass production is not really suitable or available for the workshops that produce components like this. We also have a very serious problem, certainly in the West, and I'm sure it is similar in Taiwan, in that there is a growing skills shortage. In the US and in Europe, around half of the CNC machining workforce will be retired in 15 years. But in that time, demand for CNC production is going to more than double. And if precision manufacturing keeps improving its efficiency at the rate that it historically has done, then we're going to face a $250 billion output gap by the time we hit 2030. Which is a very serious problem because the production of items that we need to service every conceivable sector is going to become slower and is going to become more expensive and more difficult to access. So, at Cloud NC, we are focused on fixing that problem before it happens. We develop technology that makes CNC machining a one-click process. We've been working on this for over 7 years, and we are releasing 2 products fairly shortly, one of which I will focus on today, which is what we call CAM Assist. One click to generate professional and efficient machining strategies in the CAM package of your choice. Now, the easiest way to describe this is simply to show you, and so I will open up a quick video here and take you through it. So what you see here is our technology integrated into Autodesk's Fusion 360 CAM programming platform. You simply click our CAM Assist add-in button and click OK. CAM Assist knows from the CAM package what tools are available. It knows what the 3D geometry is. It knows what the fixturing is. All we did was click one button, and that manufacturing problem has been sent to the cloud, where our technology is now processing it. And what it has done is it has created the machining strategy for the component, and it has filled in the CAM programming feature tree on the left, doing what would normally take an expert human machine programmer many hours in a matter of seconds. It has taken control of the software and filled in the parameters, which means that if the user wants to change something or optimize or use all of those hours that would have previously been spent doing hard manual work, doing something else, they are now able to. It really is that quick and that simple. One click and a CAM program has been produced. Now, the software is pre-release, so how do we know it works? We have a large and very capable manufacturing facility that we own based in the UK, which serves the aerospace, oil and gas, defense, and many, many more industries every day, delivering pretty much perfectly on time and with 100% customer acceptance rate. We use this technology every day, and it is about to be released to the world in beta and can be expected to become widely available towards the end of the first half of next year. Our solutions are endorsed by the foremost experts in this industry, such as DMG Mori, Renishaw, Autodesk, Innovate UK, Catapult, the Advanced Manufacturing Research Centre. And to date, in our 7 years, we've raised $78 million to develop this technology, including most recently from Autodesk and Lockheed Martin, 2 of the largest and most widely known and respected engineering companies in the world. So what is this going to mean for precision manufacturing? What is it that we're really striving for? The way that we look at the industry based on the stats, CNC machining could be a process that is almost 10 times more productive on average than it is today, because the average machine in the average workshop is only utilized for about 33% of every 24 hours, and we typically don't have nearly enough time as CAM programmers to create highly optimized programs because the batch sizes are usually too small. So machines are typically only running about a third as fast as they theoretically could do. And these two factors together mean that we're losing almost a factor of 10's worth of productivity from the typical machine. The technology that we're building, not just in CAM, but in scheduling and in cutting parameters, is going to enable us to create more efficient factories to unlock massive productivity gains globally and enable shorter supply chains and more efficient production, which in turn will mean a greener planet and one that is able to innovate faster. Because the time that we have to wait and the difficulty that goes into creating these components is one of the things that holds back the engineering industry and stops us all from innovating. So I want to live in a world where it is possible to order components at the click of a button, and whether I want 1 or 1,000 or even 10,000, those parts arrive perfectly every single time in a matter of days or in large quantities in weeks. And I can almost forget about manufacturing as a difficult thing that I'm going to need to spend a lot of time figuring out, because it has become like ordering off Amazon, and therefore the creativity of engineers across the world can be unleashed. That is us. That is Cloud NC. Thank you very much. If you would be interested in beta testing our software, please get in touch after the sessions, and we would be very, very glad to welcome you onto our program. Thank you very much.
Hello, everyone. In recent years, we have seen the explosion of IoT technologies and software in the manufacturing sector. It has enabled the evolution of manufacturing processes. The upgrade of tools and methodologies are critical to capture more value in manufacturing. We have here 2 companies at the forefront of making machining and smart manufacturing more intelligent. We have Dr. Ulysses Chang and Dr. John Xu from Herco Automation from Taiwan. And we have CEO Theo Seville from Cloud NC to share us with recent developments. So as a start to our discussion, I would like to ask Cloud NC, as automation manufacturing has been pursued for many years, how does Cloud NC see what is being done now that is different from the past?
Thank you, Kenny. So traditionally, the technology that we use to control machinery is actually very manual. So when CNC machining was first invented, we had to manually type in coordinates, XYZ coordinates, to tell tools where to go. That recently evolved into software which was able to draw patterns for us, normal CAM programming software, but we still need an incredibly expert human to tell the software what their vision is for making the component, which tools are going to be used, where are they going to be used, how fast and deep will they cut, etc. The next generation is simply one click. It is the software knows how to make the component faster and better, more productively than I ever could, because it understands deeply the physics of the process. It knows how to search the space of trillions of different ways of making that component for one of the very fastest and most reliable ways. That is the shift in manufacturing that we are seeing today.
All right. Thank you, Theo. As a question to Herco Automation, as Taiwan currently is striving to build a high-end manufacturing hub of Asia, intelligent solutions and services are key to industry advancement. As Herco Automation provides these solutions, how has these solutions evolved these past years to satisfy industry needs?
Well, we started with simple data collection devices. We approached this differently from the machine side as a hardware provider. Through that data collection, we integrated with ERPs and MESs and so on a case-to-case basis, depending on what the facility required. We slowly graduated into making more custom type of forms, reports, whatever the customer needed. And then now we've started to integrate the data that we've collected with CAM, with design software, and again, on a industry case-by-case basis. So slowly, all this digitizing, the whole trend is slowly moving towards the so-called Industry 4.0, or digitalizing this machining industry. And we're working it from the other side, as opposed to where Cloud NC, they're in the cloud, we're on the edge. So it's happening.
Okay. Thank you, Dr. Xu. As a question back to Theo, as Taiwan's manufacturing industry consists of over 96% small and medium enterprises, ITRI has always the task of trying to develop technologies and services suitable for SMEs, all the meanwhile trying to convince them to adopt digital technologies such as AI. Perhaps embedded AI functionality within machine tools might be a good approach. UK's industry also has many SMEs that have manufacturing needs, but with limited resources. What are some technologies and applications that Cloud NC view as critical for SMEs to capture and maximize value, and how does Cloud NC tackle such projects?
It's a great question. So for us, the key is to make it easier to access automation, software automation and hardware automation. The trouble that we have in precision machining in particular is the batch sizes are very small and the factories need to change what they're doing almost every single day, often multiple times a day across many different machines. It's very hard to build automated processes that can run lights out and reliably if you are always changing what you are doing. And so this industry has really struggled to move away from mostly manual processes. So the way to unlock much greater productivity for the SMEs that operate in this industry is to build as much automated, single-click, intelligent technology as possible so that we don't need to be experts in order to achieve massive productivity. And if we don't need to be experts to, say, program a machine or decide what our cutting parameters are or decide what our factory schedule is, then it becomes easier to bring talent into the industry, to hire and onboard new staff, to bring in more equipment, to grow and serve our customers faster and better. It can unblock the entire industry. The only challenge is it's very difficult to build this technology and it takes a long time. But we're working on it, and we know that the guys at Herco are working on it. It's very hard as well.
Okay, so as in the same line of thought to Herco automation, as technology barriers lower for smart manufacturing software and hardware tools, what is Herco automation's observation in how SMEs are approaching digital transformation needs here in Taiwan or globally? And what actions have been taken by SMEs? What are possible next steps along the path of digital transformation?
We see manufacturing in Asia is typically very cost constrained and also time constrained. We find that small and medium enterprises especially have a hard time adopting the type of software or the ecosystem that's typically required to digitize a manufacturing production line. So what we've been trying to do is provide simple turnkey solutions and target individual functionality to supplement or help out with the problem at hand. They probably have very specific problems that they need to solve right now for small and medium enterprises. And we just target that to try to give them something, a solution, a turnkey solution, if you will, just to try to help them out as soon as possible. And I feel that the direction forward is to package all this into some way, maybe offer it as microservices or cloud-based solutions so that you can just go out there and help out a bunch of different small businesses, each with their own unique needs, but offering a platform or ecosystem to do that from. And that will be the challenge to construct that, because I mean, in Asia, we're not very at the forefront of software, so that's something that we'll have to think about in the period to come. But we accept the challenge and we'll see how it goes.
Okay, great to hear. Thank you. So moving on to more advanced technology topic, to Cloud NC Theo. As AI technology spreads in the industry, we see a majority of their utilization used for vision applications for identification or inspection. Taiwan has developed some AI applications that monitor machine tool health and vibration levels. Are there other unique applications that can bring good value? What is constituted as a usable AI tool in terms of accuracy and effectiveness?
So from our perspective, in order to be effective, it must simply be useful. If it delivers me value, if it makes components correctly, if it saves me time, then it is a useful tool. We don't specialize in things like machine vision. We specialize in creating a robust program in the first place and trying to never create a manufacturing error in the first place. So, for example, in CAM Assist, I can't exactly talk about how it works, but one of its special features is it can never send a tool somewhere that would create a collision. It's just not an option for that tool in the first place. If you require very tight tolerances, it will automatically select different cutting parameters that are more likely to generate the correct cusp height and will bear in mind the deformation mechanics of the workpiece. It's, for us, all about creating a solution that is intelligent enough to mimic what an expert human with decades of knowledge would have known, and then deploy it instantly across any component that will ever be produced. And one of the great things about software is once you have a platform that can accept that kind of knowledge, then we only have to teach the software that, say, thin walls deform and they need to be cut in a certain way. We only need to teach it once, and then it will be deployed across every single use case forever. And that will enable for an explosion of productivity because we can put all of the world's machining knowledge into one place.
Okay, thank you. So to Herco Automation, we know Taiwan is trying to develop more advanced technologies to be used in manufacturing. AI technology deployed on the machine side and production line can require a lot of customization and system integration work, which requires a lot of time to adjust. Are there approaches to make the process more standardized or efficient? What are some unique projects that have utilized AI in its process?
Okay, thank you. As you know, there are countries and organizations worldwide are working on some AI standard currently. I think finally we will have AI standards that are applied worldwide, and maybe at that time the exchangeability and the reusability of those AI resources and tools will be improved. But I think currently in Taiwan, the efficiency problem may come from the diversity of application and strongly depend on the domain knowledge and the experience of engineers involved. So I think how to accelerate the AI application in Taiwan, maybe to build an open database that includes some successful example and reviews or its configuration strategy and method. Open these details to all others so they can have a good starting point and reference for their AI application. And I think a platform that can match those AI technology provider and those from industries is a good idea for Taiwan to develop our AI application. For examples, currently we are developing some AI systems to deal with the CNC spindle thermal behavior. So we try to use an AI model to replace traditional models and try to make the prediction of the spindle thermal behavior more precisely. And this work include the joint effort include ITI teams and one spindle builders and us all work together to provide the technology of AI and the domain knowledge of spindle design to each other and work together to develop this AI example. I think it may be a good example and a good case for our AI development in Taiwan. Thank you.
Ladies and gentlemen, good morning and good afternoon.
This is Alicia Liao from FHNet. First, I would like to introduce you the FHNet. FHNet is a new phase in smart manufacturing, but we have experienced team and powerful team that most of our manager and engineer is very experienced in IoT and data network to support the IT and OA for Foxconn Group. Our team also provide the global service for the data network mobility network service in US, China, Japan, the European countries, and also the Asia countries. So when we start our business in 2015 to provide the IoT, 4G, and 5G solutions for smart city, smart agriculture is our business. But later, to provide the global service for the smart manufacturing becomes our main target in 2018. FHNet combines the AIoT abilities and the resource of AI from Foxconn Group. That is why we can introduce the smart manufacturing solutions so quick in 2018. We know most of the enterprise, especially the small and medium company, has been implementing automations to decrease the manpower and try to rise up the production throughput. But later, they found that they are lack in data transformation, and also they found that they are stuck in the information transfer between the management level and the manufacturing line. Also the machine-to-machine communication. So they found that they are confused in the data transfers between. We know most of the enterprise, especially the small and medium companies, has been implementing automation in their company to decrease the manpower and rise up the production throughput. But later, they found that they are lack in data transformation and also stuck in the information transfers between management level and manufacturing lines. Also, the data transfers between machine and machines, and also confused in the data transfers between IT systems. So we start to introduce the concept of stages to deploy smart manufacturing. In this page, you can see the first step is the automation that is executing in this small and medium company. But you see the second is the digitalizations, also called the digital transformations. So we start to introduce the concept of stage to deploy smart manufacturing. In this page, you see the first step is the automation. That is the company is executing an implementation in their factory. Second, they should start the digitalization, also called the digital transformation. Third, they need the networking and cloud. The cloud include the internal cloud and the cloud in internet. The first step is AI. In this page, you can see how important to merge the OT layer and the IT layer. Now more and more small medium companies start to implement IT systems such as ERP, MES, SCM, CRM, WMS, and PRM. The SCM is the subscriber churn management. CRM is the customer churn management. As mentioned in the last page, they are also building the automations, but got a lag and stuck to perform an automations data flow. Since the manufacturing line, they have the automation. The automation includes the auto arms and the other equipments. So FHNet share our experience to provide AIoT to these companies to connect machine to machine, and also the data transformations between the OT layer and the IT layer. We start to help our customers to connect their machines with fixed and wireless network, also the 5G network. For the machine to machine and the machines to the, we call it the M2M, the machine to machine servers. We start to help our customer to connect their machines with fixed and wireless network, such as 5 and 5G network. The management level can have the transparent, accuracy, visible frames in the manufacturing lines by the machine-to-machine communications. This we call the machine-to-machine solution could provide real-time, transparent, and accurate frame to the management to help them to have the manufacturing lines enhanced and to optimize the manufacturer availabilities becomes very easy. Later, we found lots of the small and medium companies need to connect the old machines without the data communication. Later, we found lots of small and medium companies need to connect the older machines. This older machine has no data communications. They also ask more information, not only the status of the machine, the yield of the manufacturing line. They also ask to have the key parameters of the process that we call the KMI, the key manufacturing informations. To have this big data, the key parameters, the customer can have the key to optimize the qualities. To have the key parameters, you have the key to control the quality. So in this page, you can see we start to combine the power of the M2N, the machine-to-machine communications to obtain the KMI, the key manufacturing informations, and to combine the AI technology. In this page, we have a very good example to combine the power of the AI technologies and the machine-to-machine communications. This company has very old machines, more than 40 years. These machines, of course, they have no any data communication power. So first, we try to build up the machine-to-machine communications by the digital sensors. Then we have a lot of the big data from the machine-to-machine communications to collect directly from the manufacturing lines. And then on the right hand of this page, we also deploy the 3D inspections with the AI technologies. We implement the 3D scans on the products at the end of the manufacturing lines. So we can have this inspection result to our MES SPC systems. And second, we also have the big data that we call the KMI, the key manufacturing informations from the product lines. In this page, I would like to introduce you the power to merge the AI technology and the AIoT solutions. In this sample, we enhance 10% of the yield rate. First, we implement the 3D AI technologies to have the inspection result, and we put the inspection result to MES SPC systems. Second, we implement the AIoT solutions to this older machines. This older machines has older than 40 years, so they have no any data communication code. And last, I would like to introduce you the power to merge the AI technology and the AIoT solutions. In this project, we enhance the 10% of the yield rate for our customer. First, we implement a 3D scan system to have the inspection result to the MES SPC systems. Second, we implement the AIoT solutions to lots of the older machines. These older machines is older than 40 years, so they have no any data communication port. We implement the digital sensors on these machines to have the key management information parameters. We call the KMI informations to the MES system. Now we have two big data in our AI server. The AI server can evaluate the relationship between the KMI and the inspection result. Fourth, the AI systems hold the best operation parameter suggestion systems. From the key manufacturing information and the inspection result, the AI system evaluate the relationship between them. Then we have the key manufacturing information to provide to the operators to control these machines, and also the environment, such like the temperature, the pressure, and last, the AI system can provide the operation parameters for the manufacturing lines. Not only the key control parameters, such like the pressure, the temperature, and the timing to operate the machines. Also the parameters of the environment, such like the temperature and the humidity. So in this project, you see, to use the power of the AI technologies and to combine the IT systems, such as the MES, the SPC, and the QMS. To combine these the systems and the data transformations, you do have the power to enhance not only the product throughput, also you can enhance the yield rate. It's nice to show all of you the experience of the FHNet in the smart manufacturing. Wish you have a nice day.
Well, hi everyone. My name is Jake Moore and I'm the Global Cybersecurity Advisor at ESET. Now, I'm based in the UK, but we have ESET offices all over the world. And my job is to look after businesses and give them advice around cybersecurity and to discuss the threat landscape, which is of course ever changing. Now, my background is in the police force. I worked for the UK police for 14 years before joining ESET. So I learned a lot about how criminals work. And it's been very interesting to see how that's adapted into the world that we're living in now. So a bit more just on ESET slightly now. We've been around for over 30 years and it's been developing industry-leading IT security software and services for businesses and consumers worldwide. Now it's a journey in both software engineering and malware research, which is still key to the basics of what we deliver at ESET. Now, our high-performing software is easy to use, of course, and it gives businesses that peace of mind. But there's this big change with IoT. We're seeing it rapidly increase over the whole world now. Now, with IoT, we're seeing an industrial revolution again. So the rapid industrial 4.0 revolution. We've got smart devices hugely taking over the world now, and they are increasing. Many people around the world have them at home and in the business. And they're filled with data, but with that data, what we're interested in here is the risk that comes with it. Now, we need to be safe from threat actors who are continually changing their tactics and techniques. But also we need to be on the right side of the law. Now, we've seen governments around the world change their tactics in how they look after these devices. And we need to understand how those governments around the world are doing them, how we can implement them safely, securely, and of course, cheaply, that do future-proof themselves, because we need compliance on our side. Now, from B2B organizations, they need to increase analytical software and algorithms that can extract actionable insights from the vast amounts of data that IoT generates. And we're talking huge amounts of data. But once implemented and correctly programmed, the opportunities provided by machine learning are almost limitless. Now, it's in fact a threat of what IoT can actually offer. The data is, of course, interesting to manufacturers. They want to know about their customers. But IoT is changing. We've got people wanting to show off their latest IoT devices, from, say, toothbrushes to dishwashers to absolutely anything. I, for one, absolutely love all of my gadgets to have an IP address. It is impressive when I can do something remotely. And this is, of course, the interesting bit about it. But it's the data that goes with it. Huge amounts of data from when things are turned on, from when people are at home, when they're in the business, when they're traveling, absolutely anything. But looking at with, say, a criminal head-on, there are these attack vectors that go with IoT. So you've got third-party apps that are being used. Now, this is, of course, great when we can use cheaper applications to help build on that huge amount of data that we've got and learn from it. We can then progress and protect new devices in the future. But with that comes a risk should someone want to create another app on the App Store that might not be the genuine one. And then, of course, you've got people uploading lots of personal data, including usernames and passwords and whatever. And that can then be taken and used to attack people in extra attacks. It uses low energy Bluetooth, so it transmits the data, but there are possibilities that this can be intercepted. And not only interception, there are still going to be errors. The computer failure is just part and parcel of the technology that we're using. But then we've got the malicious attack side, and that's what I think we should be really, really cautious of in the future, because these malicious attacks aren't slowing down. Now, if we look at criminals, they're after the data, and data is, of course, the new currency. We hear this a lot of the time. That's because it is exactly the case. This data is worth so much money. Now, in an IoT-controlled thermostat, for example, it gives away some data when you're going to be using your heating in your house or your business. But nowadays, everything is smart. And that can give away when people are at home and when they're out of their businesses and homes. But there's so much more that can be found. Personal data, extremely personal data that could be used in extortion purposes. It's as much as you want to be creative, this is how criminals are doing it. And companies need to fully understand the end users, which is great. They need to know what their users are using their technology for and how they can progress. But it does attract the criminals. There are quick, easy wins with this that governments, particularly in the EU, are trying to build on now. We've got automated updates, continual updates, at least for a certain amount of time, maybe 2 years. We see some IoT devices being shipped out. They work out of the box, which is great for convenience, but of course, it doesn't future-proof them if they're not updated. 2FA, for example, multi-factor authentication, two-factor authentication, a very simple thing to add to these devices, but potentially this is down to users wanting the convenience of something to work out the box. And then we've got the classic password policies. Passwords are continually a problem for a lot of people. They struggle with how to use them in their day-to-day lives, but particularly in the UK, part of the EU, rules that we've brought in, we're building on that password policy to make sure that each device has a unique password, which helps people understand why they need it, taking a little chunk out of convenience, but a big win for security. Now, if we look at the past few years, there's been an increased adoption of IoT, tech, and digital platforms, in particular for Taiwan's SMEs to manage and transfer data. Now, this is because this is what the world wants. We want things to be smart. I'm seeing things, appliances, for example, in my local shops, they're really pushing the IoT versions of the same appliance. And like I say, this industrial 4.0 revolution, it's amazing. The automation is coming fast, but with that, it comes risk. Like I say, computer failure, errors, malicious activity, such as a botnet attack. If we look back at 2016, we saw the DIN attack. It was huge and it took the world by storm. We had no idea that this was even possible or what it could even do. And on top of that, you've then got reputational risk. We mustn't ever underestimate this reputational damage that it can really do. There are fines, of course, in some parts of the world, and these companies can withstand those fines, but it's the reputational damage which is key here. Now, lastly, I want to just touch on the big word of regulations. This is where it's different all over the world. So we'll have different regulations for different regions, and of course that makes sense. But the forthcoming EU Cyber Resilience Act will place security obligations and on IoT manufacturers supplying products particularly aimed at the EU market. Now, this improves the situation greatly. We need these regulations to safeguard people who genuinely don't care about what they're doing with their data. They just want, like I say, these items just to work straight out the box and show off to their friends. But we need to be protecting that data where we can, their devices as well. Now, at ESET, we do have a very impressive threat intelligence feed that comes out and helps businesses. It gives in-depth, up-to-date global knowledge about specific threats and attack sources, which does help in the IoT space, because this is a very fast-moving area. And this enables organizations to detect advanced persistent threats, APTs, block suspicious domains, and so on, and prevent botnet attacks. Now, for those of you that may have an appetite even more so on APTs, we've got our reporting service as well, which is extremely interesting. Now, APT groups are always looking for the latest ways in which they can abuse or exploit any vulnerability that may lie. And that might not be in the technology itself, it might just be the safeguarding processes that are simple to overcome. We've still got some devices being shipped out with the simple admin situation with username and password. And once they can be exploited, that's when the bigger picture really hits out, like I mentioned, with botnet attacks, which can take down a business with a DDoS, but then personal attacks on targeting devices with terrible passwords or limited two-factor authentication. So there's a very short, rapid way through an adoption on IoT. Thank you so much for listening. There's loads more on this on our website, and what we do with We Live Security, we've got a fantastic research unit based in Slovakia, always looking at the latest threats. And you can follow me on Twitter for, again, short and snappy bits of advice all around IoT and anything else that might take your fancy. So thanks very much. I've been Jake Moore, and this has been my talk on the IoT adoption and what's to come in the future. Thank you.
The knowledge of data as value for the company has pushed forward the trend of industrial digitalization. To maximize value capture beyond edge computing for specific manufacturing tasks, looking at the whole systems and harmonizing operations is critical for a company. The progress to integrate more intelligent functionality as well as protection measures into MES ERP systems can bring rewarding benefits and minimize risk. Today, we've invited industry specialists from Taiwan's FHNet and UK's ESET to share with us their observations and views on how industry is developing. As a start to FHNet from Taiwan, as more IoT technology is being adopted by small, medium, and large companies alike, managing all the systems and data in a comprehensive method is critical. FHNet specializes in creating a network to make everything integrated together. What does FHNet see in different needs and approaches for small and medium companies compared to larger companies?
Hello, this is Eric from FHNet. Okay, the question, the larger companies already view data security as a business philosophy. Smaller company like takes more gradual approach to upgrading IT and OT systems. Especially, there is no that much of the professional IT engineer. With more and more machines being connected to MES network, considering cybersecurity technology today, what is good approach for companies and assess their current level and plan a roadmap to upgrade cybersecurity capabilities and scaled up. I think this is very good. This is very important things.
Okay, thank you. So, as minimizing risk in terms of IoT protection is very important. As a question posed to ESET, as larger companies already view data security as a business philosophy, smaller companies take a more gradual approach.
I'm wrong. So, I think wrong. So.
那经理，我还听得到你的声音哦。
No, okay.
So as to ESET, a question to ESET. As larger companies already view data security as a business philosophy, smaller companies take a more gradual approach to upgrading IT and OT systems. With more and more machines being connected to MES networks, considering cybersecurity technologies today, what is a good approach for companies to assess their current levels and plan a roadmap to upgrade their cybersecurity capabilities and scale up?
So I think this all comes down to security by design. We've got to be looking at devices throughout the whole phase, from design right the way through to shipping it in the box with security in mind, which in years gone by we have probably forgotten about a little bit, because maybe trying to cut costs, and we know that the end user just wants the device to work out the box and conveniently just plug and play. But now we've got to be thinking about that design all the way through, keeping people secure, keeping them up to date, throwing out updates as and when timely, when threats could be affecting those devices and their data, giving them the opportunity to add two-factor authentication, and giving them advice on passwords. For example, giving all of these devices unique passwords from the get-go. Now, this is something that the larger organizations have been thinking about over the past few years, but it trickles down to the small and medium-sized businesses in slower time. And this is quite natural. We see this in other areas of business, but we need to be securing those devices, because this is the future. Most things are going to be delivered with an IP address. Unfortunately, if you like it or not, we find that people, even if they don't want those devices to come smart, they are going to be given those smart capabilities in the future. So we need to be protecting as best we can. They may not understand the risk, they may not even know there is a risk, but I think we have this due diligence to give them a secure capability of using those devices securely.
Okay, thank you very much. So to FHN Manager Liao, an important part of IoT and cloud networks is to incorporate AI functionalities to manage, analyze, and act upon all the data communicated. For the manufacturing sector, AI needs to be highly customized and monitored during early development phases to satisfy needs and facilities. How does utilizing AI technology within networks capture and maximize value?
Okay, I think this is a very good question. And it also match the past 2 years what we have developed for the AI technology for the manufacturing. First, we performed the machine-to-machine. We call it the machine-to-machine solution to connect the machines to a server to collect all the data for the process, such as the parameters for the process, the temperature, the pressure, all the things, all the key parameters, all we need. Okay, and then we collect this data to MES system. Now we have all these parameters. We call it the big data of the process, and then the MES system to collect we call it the quality defect result to the quality management system. So now we have two big data, the data, the key parameters to produce the products, and then the big data of the quality defect result. So we use the AI technology try to find the rules, how to optimize all the control parameters, and then we bring this data back to the machines to control the process, to optimize the qualities. So this is what we do and performed in the past 2 years. And we also get some very good, we call it the result or the sample on the manufacturing lines. Yes, especially for some companies, they are very old companies. It's more than 40 or 70 years. Their machine is very old. So they have, first problem is how to collect all the parameters. They know this parameter may be the key, but don't know how to impact the qualities. So we perform the machine-to-machine connection to collect all the key parameters, and the second is a quality defect results. The another big data use AI technologies to find their relationship. Maybe some parameters, just like the pressure is the best pressure is around maybe 100 psi to 200 to 110 psi is the best areas to produce such the products. Then you can use the AI result to set up the limitation to see to see if the pressure is higher or lower. Then we suggest to the manufacturing. Then there will be the alarms or alert to the handset or to the make a noise to make alarm for the lamp for the voice to the voice. Then the manufacturing line managers they can know what the parameters in the process in the manufacturing line is out of control. Maybe they will produce we call the NG products. Okay, so this is what we performed in the past 2 years for the AI technology and to combine the machine connections.
Okay, thank you, Manager Lau. So as FHNet builds solutions to connect more and more machines, it involves expanding networks and more machinery and equipment is digitally connected. So as a question to ESET, the increase of data communicated is becoming ever more complicated. Are there more intelligent tools to monitor network status? And what kind of new cybersecurity IT technologies are being looked at right now?
So communication is one of the areas that criminals will look to intercept. So the more areas of communication, the more attack vectors that we have got. And this is something that sometimes gets forgotten about in that manufacturing phase. And as we increase, we are naturally going to see the attacks also increase on there. Now, the more we've got in this industrial 4.0 revolution, we've got to get our heads around it. The automation is coming fast. And with that automation, there is also going to be a level of risk that comes with it. And that isn't just malicious, like I'm alluding to with cyber attacks. You've also got computer failure to look at. But if you look at the malicious activity that can be surrounded here, you've got botnet attacks or larger scale DDoS attacks, which are continuing all over the world on businesses. So when it comes to that communication, we must be making sure that lines are encrypted and data is secured at both ends. Encryption is a big part of this.
So thank you, ESET, for your answer. So as a question to FHNet, as you build more IoT platforms and cloud technologies, FHNet also has technology to deploy 5G networks for manufacturing facilities. And it's also developing technology for ESG and environmental protection. What are some success use cases for 5G and AI deployment? And what are some approaches to incorporate ESG benefits that FHNet takes for your solutions?
Okay, that's a very question. That is what we are doing, and we have performed in the past year, and we will develop this business in the next year. Okay, I have a very good sample to introduce to you. We have a partner. Their factory is use the coat to produce the skin. The skin is the source for the manufacturing lines, and their problem is how to decrease the using of the coat, because the coat will make a lot of pollution for the air. And the second they need is how to decrease the pollution of the air. This is very hard to do. So we also use the AI technology and to combine the 5G network. First, we implement the sensors in this factory to collect all the related, such like the fans to import the cold air. And I remember there is 4 speed of the fans. One is to import the cold air, the fresh air, and the second fan is to make the air has already burned out of the equipment, and the third is the fans to lead the hot air after burned. But it's also some oxygens can be used, and the temperature is high, so it's more efficient. Another speed of fans is to load the coat into the equipment to burn, and such as some. And then there's we implement the sensors in the steam into the equipment to collect the steam to see how the pressure was produced and the temperatures. So a lot of, and also the sensors in the tunnel to lead all the already burned air into the out of the factory. So you see there's a lot of the sensors have to implement, and there is how to use fixed network such like the Ethernet cables to connect all the equipment. So we use the 5G technology to connect all the sensors to collect all the data, and then we have a lot of big data. Some data is to how to produce the steam, and some data is to collect the result of the steam and also the air, because our government had some rules to observe the air. You know, the air after burned, there are a lot of pollution in the air. So we have to analyze. We have equipment connected in the tunnel to analyze a lot of such the materials in the air. So our AI server to collect all the big data from 5G network and connect to the sensors. And then after computing of the AI server, we have some suggestion. We call it the optimized operation parameters. We suggest these parameters for the operator. Then they can control the best. They can operate and control all these fans, these equipments to make the best way to use the lowest cost and to have the more air that is below the government's rule. Okay, so you see we combine the 5G technologies for the communication to collect all the parameters, and we also use the AI technologies to help the factory to decrease the usage of the code, and also to increase the efficiency of the machines, so they have the lower cost, and also they produce fewer polluted air. So this is a very good sample how we have done in the past year.
Okay, thank you, Manager Lau. So as talking about 5G networks, as a question posed to ESET, Jake, with 5G networks being able to transmit data and lower latency, are there potential cybersecurity risks that traditional networks have not encountered? And what are some key areas to address and protect that can be taken?
So with 5G, there comes a lot more data. And, so can I start again? I'm struggling to hear when you've got your headphones in. Let's start that one again. Okay. So with 5G, there becomes a lot more data to be playing with, and we're seeing this communicated all across multiple devices. And with that, there are going to be more attacks on this. Now, we're having to look at how we can see what criminals are going to be doing with that. And we've got intelligence feeds that are looking to detect advanced persistent threats. Of course, they could be using 5G networks and block suspicious domains and even prevent botnet attacks. And with that, especially at ESET, we look into these APT reporting service services. And you can see the analysis and the adaptation that they are able to create. And of course, 5G is what we're looking at into the future, and how we can adopt with the increase in such services.
Okay, so as sort of just a short brief discussion between Taiwan and UK on IoT platforms and their cybersecurity risks and protections. So we thank both of you for joining us today, and we wish to see you soon in the future. Bye.
Thank you.
Okay, so I guess that would conclude this part of this recording.
Okay.
Thanks once again. Thanks once again, Jake, for helping us.
Anytime.
Yeah.
Thanks. All right.
Thanks.
See you soon.
Feel like I like listening about cybersecurity stuff.
Good.
Even though I'm not that familiar with it.
All right.
Okay. Thank you.
Well, yeah. See you soon. Bye.
Yeah. Bye.